In this video, we're going to practice identifying composite functions, particularly what I like to call a quote inside function and a quote outside function. I think this is a really important skill when we need to use the chain rule coming up in the next page. So each function below is given as h of x equals f of g of x. We want to find f of x, which if you look f of x here, this is going to be our outside function. And then we want to find g of x. Well, g of x is the, quote, inside function. So we're breaking this big function down into two smaller, simpler pieces. So if we start with part A here, we've got h of x equals the square root of x squared minus 4. To me, I look at this, I see first of all the square root, and then I see this inside part right here inside of the square root of x squared minus 4. So I'm going to take the inside function, g of x, to be that x squared minus 4, the part that's, quote, inside of the square root. That would mean then that the outside function, f of x, how I'm going to find that is I'm just going to take out what I said was the inside function, x squared minus 4, and I'm going to replace it with just x. So I should have square root of just x. And for all of these, I should be able to check my answer if I was to take my g of x function and plug that in for x. I should get exactly the same thing as what I started with. So all of these, it's really nice we can check our work on each one of these problems. So let's move on to our next problem here. Next, I've got h of x equals negative 5 times e to the 0.2x. Here, this one is a little bit tricky. We're still kind of learning exponentials. Maybe we haven't used them in a while. To me, when I see a function like this, I see this piece right here. When we have x within an exponent, that is almost always going to be a really good candidate for our, quote, inside function. So I'm going to take my inside function to be g of x equals 0.2x, just that part that I said was, quote, inside. For my outside function then, f of x, I'm going to take that whole function, which is negative 5 times e, and then instead of that 0.2x, I'm just going to replace that with x by itself. So we should, again, be able to check our answer here. If I was to take 0.2x, plug that in for x, I should get the exact same function that we started with, which is good. That's what we want. So let's look at just a couple more here. Part C, here I've got h of x equals 4 times the quantity x plus 9 squared. I'm going to break this down to an inside part and an outside part. Now, in general, not always, but in general, when you have parentheses like this, that's going to be a really, really big hint as to what your, quote, inside function should be. Your inside function is usually whatever's inside of the parentheses. This isn't true 100% of the time, but it's true, I would say, the vast majority of the time. It's a good kind of little rule of thumb or a shortcut that we can take here. So I'm going to take this inside part right here to be x plus 9. So I'm going to take my inside function to be g of x equals x plus 9. And then the outside function, f of x, I'm going to take out that x plus 9 and just replace it with x. So f of x would be 4, and then instead of x plus 9, I'm going to have 4x squared. Again, we can check our answers here. If we take x plus 9, plug that in for x, do we get the exact same function that we started with? Here we would have 4 times x plus 9 quantity squared. Yes, we would get the same thing. That's exactly what we want. And for our last example here, h of x equals negative 1 divided by x squared plus 5x plus 6 quantity squared. I'm going to encourage you to just pause the video here and see if you can identify what would be a good inside function and what would be a good outside function here. So why don't you go ahead and pause the video real quick and try practicing that on your own. And hopefully you have something written down on your paper that we can check. Here, I see these parentheses again. I think that's going to be really helpful in identifying what your inside function and what your outside function should be. Your inside function, g of x, should be x squared plus 5x plus 6. And then our outside function would be f of x equals -1 divided by x squared. Again, we can check our answer. If we were to take x squared plus 5x plus 6, plug that in for x, we should end up with exactly the same function that we started with. Now, I will add just a couple of small details here at the end. There is usually multiple ways, and I'll say really always, there's always multiple ways I could solve these types of problems to have a, quote, inside function and a, quote, outside function. However, I do think there's usually one, quote unquote, best way to separate these. The whole point of breaking these problems up is so that we can take derivatives a little bit easier. We want to take one kind of complex function and we want to break it down into two smaller, easier to work with functions. So what we're going to start with when we jump into the chain rule in the next section is we're going to start with a function that looks like this. That's pretty complicated, that we maybe don't know how to take the derivative of. But then we're going to break that down into two smaller pieces. G of x, well, I know how to take the derivative of x squared plus 5x plus 6. That's no problem. I can just use my power rule there. And then f of x equals -1 over x squared. Here you could either use the quotient rule, or if you're clever with your exponent rules, we can rewrite that as -x to the -2 power. Either way, we know how to take the derivative of that function. So that's going to be kind of our goal with the chain rule, is to, again, start with this complex looking function that we maybe don't know how to take the derivative of, and break it down into two smaller functions that are easier to work with, that we do know how to take the derivative of.